Hello Gideros. Today I'm going to be talking about a new class for Gideros called Layout. And Layout is a Lua library written for Gideros by one of the main contributors to the Gideros development system, Nikolai. The motivation for Layout is to allow graphical user interfaces to easily be written using Gideros. And this is useful for games, but it also allows you to write line-of-business apps within Gideros, and we'd like to encourage people to use the 2D graphics facilities of Gideros to create business apps as well as games. Gideros already comes with a large number of different sprite types, but one of the things you need when you're creating, for example, dialog boxes and other buttons and widgets is some way of arranging them on the screen in neat rows and columns without having to manually place them. For example, in Gideros Studio itself, there are many dialog boxes. For example, you can find something using Control F, and the dialog box appears. It has input fields, it has buttons, and different types of buttons, and everything needs to be arranged in neat rows and columns. It would be obviously tedious to orient and arrange these things manually using a Gideros set position command. The other thing you need with a graphical user interface system is the ability to scale things automatically. For example, if you look at the preview window that Gideros Studio has, it allows you to preview lots of different bitmap images. Even though they're different sizes, the preview window will scale them neatly so you can see them within the same sized box. So being able to scale things automatically is very important. Again, trying to manually scale things using set scale would be very tedious. You'd have to guess at exactly what scale to do, and it would be a fractional scale. So all these images, although they're all different sizes, as we can see from down here, you can actually see the number of pixels. They're all fitting in neatly to this little preview window. And of course you can do this within Gideros Studio, but we'd like to be able to create our own apps to create these sort of panels with images in them. The Layout class allows you to do all these things. Layout is available on GitHub and it's free to download. So you can download it by using this button. And it's a Lua library, so there's no plugins, no extra C++ code that needs to be added to the Gideros core engine. Rather, it's all written in Lua. And this is the actual file, layout.lua. When you download Layout, as I've done here, you can see this is what you get. Layout.lua is the actual main code, so you can read through this code, and it's all written in Lua, so it should be fairly readable if you want to see how it works. But in addition, the author has provided many examples, which run from this main.lua file, which also loads in additional code from this examples folder. So let's have a quick look at how it works. If I pop up the Gideros desktop player and run it. So you can see there's some animations, and this is a layout. It's a single layout filling the whole screen. A layout, by the way, inherits from sprite, so it's a type of sprite. So when you come to add it to the screen, you do stage, add child, layout. So everything you can do with a sprite, you can do with a layout. Of course, it has many more features. You can see it responds to mouse hover, and it has built-in animations. If I use my arrow keys, you can also highlight different buttons here using the arrow keys. And in fact, these buttons have just been created using the basic text field bitmap type within Gideros. So you don't necessarily need special widgets. You can just use simple text fields. And there's animation as well. You can see the whole thing scrolls. I don't have to write that scrolling facility manually using Lua code. It's all built into the layout. And if you go through some of these things, you can see how it flicks from one to another. What it's just done then is it's got rid of the first layout on the screen. It's removed it from the screen using remove from parent. And it's now added a new layout, created a new layout, added it to the screen using add child. So it's all standard stuff when it comes to adding and removing the sprites, but these layouts are obviously special types of sprites. So this is a kind of dialog box you might create with OK and cancel buttons. If I click OK, then down here on the left you can see it's printing out OK. But you can make it do anything, including dismissing the dialog. This button goes back to the main menu. So you can see how all of these examples are attractively laid out within a layout itself. So layout is very useful even for demonstrating itself. Some of these examples are rather complicated. I'm going to start off with the manual grid example, which is one of the simplest examples, but actually one of the most beautiful as well. You can see that, exactly as I said before, it's possible to lay out and arrange these different size bitmaps without having to manually position each one. And you can see it's also scrolling automatically, and I'm using the arrow keys now, and there's a highlighted fruit. I can highlight whichever fruit I want, and that's all this example does. Nothing happens when you press enter or click on any of the things. So in this tutorial I want to go through this fruit example, and we go to the examples. You can see the code for this, and it's called manual grid. So I can examine the code here. I'm basically going to write this code, but I'm going to make it a little bit simpler than this and just extract the code as a standalone program. Okay, let's get started. We'll open a new project, and I'm going to call this project manual grid and allow Gideros to create a directory for my project. So the final project will be stored here. Okay, and I have an empty project, and I'm going to need to add a new file, a main.lua file, and I'm also going to need to add the layout code itself because I want to go ahead and create layouts using layout.new. To do that, I'll need to link my project to the layout code. What I could do is manually copy layout.lua into the same directory as I will create my new project, but I don't want to do that. I want to add it where I've downloaded it. And in my case, I've downloaded layout into this layout folder. So all I need to do is link in layout.lua. The other Lua files within the layout project that you would download from GitHub are just the example demo code. So I'm going to link it to layout.lua. You can see if I click on layout.lua, it tells me where it's located. So it's not located in the same directory, even though it looks like it is from this directory structure here. It's actually located one directory up, then within layout, and it's layout.lua. So in Gideros, you don't always have to have all the files in the same folder. The benefit of referring to the original layout code is I can then update the library to the latest version if the author adds new features or fixes bugs without having to recopy files into each one of my projects, because I might have 5 or 6 projects all linking to the same layout code. So it's useful to have a link like that. Okay, so with that code in place, I should now be able to create a layout. So let's go ahead and do that. Layout equals layout.new. When you create a layout, it takes a single argument, which is a table. And this table can be very large with many keys within it if you want to define many features, or it can just be empty, in which case you're accepting all the defaults. And let's add my layout to the stage. Well, I won't see anything just with that. I need to do something a bit more. Let's set the background color of this layout. I'm going to set it to red. Red, green, blue, and the full channel of red, and nothing at all for green and blue. But actually that still won't see anything because the default alpha is 0. So I need to set background alpha to 1, making it fully opaque. Okay, create the Gideros player and run it. That's my layout. Doesn't look like much, but it's a red screen. What I've done is I've created a blank layout with a red background which fills the entire screen. Just to show you I've actually done something here. Let me take relative width equals 0.8 and relative height equals 0.8. The default for both of those is 1, which means it fills the entire screen or the entire stage that you've added it to, or whatever sprite you've added it to. But if you set these to 0.8, then it should occupy less of the screen, and we can sort of see the whole thing. So now you can see the whole layout there. The next thing I'm going to want to do is to add some cells to the layout. So let's keep this simple to begin with. Let's say cell rel width equals 0.5, and So what this is telling the program is that there will be cells of 50% of the entire layout width on the screen. So this layout that I'm creating now will consist of sub-layouts, each of which is a quarter the size of the entire thing. So I'm going to create a total of 4 of them. So what I can do now is I can add layouts within my main layout. Let's just put another comma there. So within a layout I can go ahead and put actual sprites within it, and they can be any sort of sprite, but I'm going to use actual layouts here. So to create a new layout, which of course is a type of sprite, I just do layout.new as I did before, and this time I'm going to say background color equals, let's say, blue. No red, no green, lots of blue, and background alpha equals 1. And I need to say which row and column I want to put this in, because I've said my original layout will be divided into sub-layouts of size 50% width, 50% height, so occupying a quarter of the entire original layout. So I'm going to say column equals 0 and row equals 0. It starts numbering at 0. Let me see if I got the right number of brackets. I think I do. Okay, let's see if this does the right thing. There you go. So I've created a layout with another layout inside it. Okay. The other columns I haven't done anything with, so you just see the background coming through, the background red color. But of course I could go ahead and create more layouts like that. So let's create just one more to begin with. Let's make this one, let me see, what is it? No red, lots of green and lots of blue. So that so that's yellow, isn't it? No, that's cyan, green and blue, cyan. Okay. I'll put this in column 0, column 1, row 0. So that will be this one here, should now be cyan. Right, good. So finally I got it right. You need to have the right number of brackets. One thing you may notice in Gideros or Lua throughout is if you have a function which has just a single argument, which is just a table, you can remove the outer brackets, the outer round brackets, without any problems. And generally I don't like doing that because I want to remind myself it's a function, but in this case there's so many brackets you could easily get confused. So why don't I just do that, be a devil. I'll get rid of that outer bracket right up here as well. So you can see at its basics, a layout is just a patch of color, a solid color. Okay, the next thing I want to do is actually start adding some fruits to this project. So let's go ahead and add some existing files, and I'm going to use the example graphics that come with layout itself. So here's where I've installed layout on my computer, the actual library. It comes with various images and resources. What I want to do is add this fruits.ping and the accompanying file called fruits.txt. So if I open both of those, they'll be added to my project. Again, they're not in the same directory physically, but that's okay, and Gideros will tell me where they are. They're in one step back, layout, resources, fruits.ping, and similarly for the text file. Now this fruits.ping is a texture atlas, which is one of the things that Gideros supports. So what that means is it's a series of separate bitmap files that have been composited onto a single larger bitmap file, which in this case is 2048 by 1024 pixels. And the reason you do that is to, one, reduce the number of pings floating around in your app, which might run into hundreds if you have a game or something like that. But it also allows Gideros to use memory more efficiently, because if you load a single bitmap into memory and can constantly reuse it, it's more efficient for OpenGL or DirectX than having lots of separate bitmaps all floating around in memory as individual resources. To actually use these bitmaps, you've got to extract them from the texture atlas. And the way you do that in Gideros is you supply also a fruits.txt file. And this text file just contains the name of the original bitmaps and the location of each bitmap within the big texture atlas. Of course, you wouldn't write this by hand. What you would do is you would use an auxiliary Gideros product, which comes with your installation of Gideros, called...
So if you go to the Gideros group,
So Gideros Texture Packer, that's what it's called. So this was a simple and small program that allows you to composite various bitmap files and output a single texture atlas, which is a ping file, and also the accompanying text file, which allows you to find these things. It's called Texture Packer. It's quite easy to use Texture Packer. It's almost self-explanatory, so I won't go into it in this tutorial. But suffice to say, we've already got the raw or the final result of Texture Packer, which is these things. So I now need to add these to my program. So to help me with this, I'm going to create a list of names, which is the names of all the fruit, and it's a table which will consist of strings. So each string will be the name of the original bitmap file. So we have fruit, which is the overall picture of lots of fruits. That's going to be a major part of our dialog box. Cherry, banana, strawberry, elderberry, melon, fig, and apple. So these are all the fruits that we need. Those are just names, of course, they're just strings. And I need to get a reference to my texture pack. I need to create a texture pack using texture pack pack.new. And this is one of the primitive features within Gideros. You don't have to write this yourself, it comes with Gideros. And it allows you to create a whole load of textures from a single large texture atlas. So the input to this is fruits.txt and fruits.ping, the two files which define the texture atlas, or the texture pack. I now want to extract all the bitmaps from this texture pack. So I'm going to create a another array or table called bitmaps, which will consist of a whole load of Gideros bitmaps. So I'm going to loop over all the different names within my names table. For I equals 1, comma, number names, hash names do. Hash names is the number of entries within my table, which I can see is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, and then I'm going to say bitmaps. And now the key I'm going to give this thing is going to be names I. Now, what is names I? Names bracket I. Well, if I equals 1, then we're going to have names 1 equals fruits. So it's a string. So what I'm doing here is I'm creating some keys within this bitmaps table called, for example, bitmaps fruits. Square bracket. Bitmaps orange will be another one. And you can do this in Gideros. You can have keys that are anything really, as well as keys being numbers. When you access a table, you can access it by numbers like 1, 2, 3, like I'm doing here, or I can access a table using strings such as fruits or orange. So what this loop is doing is it's going to create a whole load of keys within this table. And of course I do all this on the fly. I don't have to declare or define anything. That's nature of Lua. I'm declaring new fields within the bitmaps table on the fly. So I'm going to create bitmaps orange equals something, bitmaps grape equals something, and so on. What is that something? Well, I need to create a new bitmap using bitmap.new. And I can create a bitmap from a texture pack using this field method fruits pack colon get texture region. And that is based on a string, which is the original file name of the bitmap file that went into the texture pack. And that, I can recover that from names I, which is going to be, for example, orange, dot concatenated with .ping. So that will give me orange.ping. And this is how I extract bitmaps out of a texture pack in Gideros. That's all I need to do. So now I've created all these bitmaps, 10 bitmaps. I can go ahead and add them directly to one of the layouts. And in any layout, you can add sprites within it. If you look at our outer layout, layout.new here, the biggest layout which contains layouts, it actually contains 2 sprites, both of which are layouts. I'm now going to make it so that one of the layouts, and eventually both of them, contains a sprite. Which sprite shall I put in? Bitmaps dot, let's say orange. After all, I have a field called orange within bitmaps, and notice I can equally do this in Lua. That's the kind of Python way you do it, but Lua has additional syntactic sugar where I can also do this. Orange. So the very last parameter, or actually it doesn't matter what the order is, the parameter that doesn't have a key, doesn't have something like row equals before it, is the actual sprite that the layout will show, and you can have multiple such sprites. So I'm going to have a bitmap within my layout, and then that layout is within a bigger layout. So hopefully we'll start to see something interesting. So you can see this works as expected. We can see the orange bitmap in the column 0, row 0 element of our larger layout in the top left cell. And you can see that the oranges are automatically scaled to fill within that layout area. So I don't need to manually scale them, I don't need to manually position them, I just need to say that they are in column 0, row 0. Let's try adding another one. So let's have bitmaps dot cherry in the next one, namely in column 1, row 0. So there it goes. And you can see in both of these cases what's happened is the system has used a type of scaling called letterbox to fit the bitmap neatly within the cell. So what that means is it scales up, it expands the bitmap until it fills the entire area without distorting its aspect ratio. So it leaves behind these empty areas, and that's why it's called letterbox. So it looks good, but there could be a lot of empty areas. There are different scaling modes possible within layout. So if I type sprm, which means sprite mode, then I can also choose layout dot let's say stretch. Let's just move that over here. Stretch is another mode, and that will simply fill the entire cell even if it means distorting the aspect ratio. So there you see the oranges are no longer spherical, they're being distorted in a vertical way. And there are several different modes. The default one we've already seen is the letterbox, box 1. But another one I'm going to use is called crop, and that means you will magnify the picture as much as possible to fill the entire cell without distorting the aspect ratio, but possibly losing some of the picture off the side, so some of it will get cropped and will no longer be visible. It produces a nice appearance in certain circumstances, and that's the one we actually want to use in this example when we start to finish it. So you can see it's been cropped at the left and right, but it looks pretty good. It's kind of zoomed in on the action part of the picture very well. And all this would take a lot of hassle to do using set scale or set position commands. So layout is doing a lot of work for us here. Okay, I'm now in a position to start doing what I actually want to do and get all these fruits in place and reproduce, therefore, the manual grid example. In the manual grid example, I don't have a cell relative width of a half, but rather I have a third. So I'm going to have 3 cells along in the width direction, and in the height direction I'm going to have still a half. And by the way, in Lua, this is indeed 0.333. It is not 0 as it would be in C. So you can do this 1 divided by 3 without any unexpected round-off errors. Okay, and what I can do now is I don't need these background colors, right? They're just kind of for illustrative purposes. So let me start to get rid of these, and what it will do is the background will be transparent. The sprite inside will still be visible, but the background won't be visible. Sometimes you want a background color, sometimes you don't want to see a background color. Let me just put this in a different order. The first one is going to be fruits. So let's get rid of that one there. I'm just putting it so it now looks the same as the example. Column 0, row 0 will be the big bunch of fruits. And we're going to have the sprite mode of layout.crop. Again, let's get rid of this one. Now we move on to column 1, row 1. And moving on to row 1, let me just show that before I expand on what we're going to do to make it span several columns, which it will do. But if we just do the bitmaps.cherry first, that's row 1, column 1, row 1. Again, let's have layout.crop, like that. Yep, so we see what we want to see.
But of course you can't see all the 9 fruits, or the 10 fruits, because you can't scroll. So some of them are scrolled off the bottom of the screen.
So when we say cell rel height is 0.5, that means half of the total height of the layout, but not the the visible height of the layout on the screen, not the entire height. So the layout continues beyond the bottom of the screen, and we actually can't see it. So to allow ourselves to see it, we'll have to introduce scrolling within this layout. But before we do that, let me extend these fruits so that it covers 3 columns. We want the fruits to be extended across 3 columns. And to do that, we just do the extra parameter cell width equals cell W equals 3. So by default, this is just 1. So what we're saying is the fruits will start on column 0, row 0, but they'll extend across 3 columns. So we see something across the top. Okay, let's run that one. Okay, so starting to look like just what we want to see. One thing you'll notice is that these layers just touch each other immediately with no spaces between them, and sometimes it's nicer to have the sub-layouts with a little space between them, so that there's a separation between the various components in your graphical user interface. And we can do that easily within the major layout. We add an additional parameter, which is cell border width, cell BRDW. And we're going to have that in pixels. So we're going to leave a width of 5, and cell border height will also be 5. Okay, so you can see there's a separation between the various layouts. My background layout, I can now stop it being red. I don't really want to see these red bars. I'll just delete these things, background color, and I'll also delete these relative heights. So I'll make it the entire height of the screen. And I want the layout to fill the entire screen, the entire stage. There you go. So now it looks a lot like the manual grid example that we saw right at the beginning within the layout examples that are provided. But it still can't scroll. So the last thing we really need to do is to make it scroll. To make it scroll, you need to tell the big layout how many rows and columns it's got. So to do that, we say cols equals 3, there are 3 columns, and rows equals 4. And notice the difference between cols and col, and rows and row. It's plural versus singular. So you can see that if you multiply the number of columns by the cell rel width, you can see there's no scrolling going on, because you've got 3 times a third equals 1. So there's no horizontal scrolling. But on the other hand, you've got 4 times a half equals 2. So there will be 2 screenfuls of scrolling in the vertical direction. So you can always tell whether it's going to scroll or not by looking at that. The last thing I need to do is activate scrolling by saying scroll equals true. Okay, let's see if we can make it scroll now. Yes, there we go. And we can see all the remaining fruits, and it scrolls nicely until the mouse clicks. Okay, all that remains to be done now to finish this example is to set up a selector. A selector is like a cursor within the layout itself that allows you to select one of the elements within the layout using the arrow keys, or maybe using a controller, an external physical controller in a game. It's very easy to add a selector. All you do is you say layout.select, and then you pass it one of the layouts within the main layout. So I want to pass it, let's say, the orange one. There are various ways to access sub-layouts within a big layout, but in this case it's easier to access them by column and row. So the orange one has 0, column 0, row 1. So if I do that, if I say layout, that's the name of my big layout, and I say 0, 1, that will access the 0th column and first row of the layout, namely the one with the orange inside it. So I'm now activating the selector and putting it in an initial state, and the user will be able to move it around. So let's check that. Okay, so you can see the orange is a little bit grey. It has a grey overlay, and by using the arrow keys I can move this overlay around and select things as if under cursor control, and you notice the whole thing scrolls automatically as I do that. So this is very useful for games, for example, if you're using an external controller to select various options on the screen. It's very easy to set up. The exact nature of this selector, you can vary that. At the moment it's just a grey rectangle which is mainly transparent, but you can change exactly how it looks within various other parameters. So that's about the end of the project. I want to draw your attention to the appearance of this layout, because this is kind of typical of the sort of layout you might generate. You've got a big outer layout with various parameters, global parameters defining how it looks, and this big outer layout is added to the stage. It's a top level layout. Within this layout you have various child layouts, and at the bottom line, when you get to the absolute lowest level of layouts, they have a direct sprite being added into them. So the bottom level layouts have a sprite in them, and they sit within other layouts, and then they are within more layouts, so you have a whole hierarchy of layouts, and then the topmost layout, you add it to the stage directly. And that's a typical kind of structure of layouts. So you have lots of layouts within layouts, etc. But it allows you to create these complex tables and columns of bitmaps, text fields, but you can put absolutely anything in there. So if you have a button class, for example, and Gideros actually comes with a button class, then you can add it to the layout just as you can any other sprite. So this button class, if you want to explore that, is one of the examples that comes with Gideros. This button thing here. So that's a pre-existing widget, and you can just click on it and it does what you expect from a button, but you could equally add that to the layout because it is a sprite, and anything that inherits from sprite is a sprite. This button is defined as a class which inherits from sprite. Because it is a regular sprite, it can be added to a layout, so you can arrange buttons in this way, and you can arrange text fields in this way, sliders, or any other sort of widget that you might need. Okay, so if you want to find out more about layouts, have a look at the website. So this is the GitHub website for layout, and it has quite a lot of documentation. The most important thing, well, it's all good to read, but one of the most important parts of it is the list of all the layout keys. We've already examined some of these keys. We had the relative width of a layout and the relative height, and then the columns, number of columns, number of rows, the cell border width and border height we've encountered today. Other things are rather similar. The column number for a particular layout, and the cell width if it needs to span several columns, cell height if it needs to span several rows. We talked about the selector, and we talked about various details of the sprite that affect the sprite that's within a layout. So you have the sprite mode, which might be letterbox or whatever, and you can see the constants available right at the top here. No scale, letterbox, stretch, fit width, fit height, and crop. So we've explored some of those. The background color and the transparency for the layout. And down here you can see these are more advanced things for inheritance, which I'll get onto in a later tutorial. There are also some callbacks. So on add, on remove, and on press is probably the most important. So if you click on the layout, you want something to happen. We'll cover that in a later tutorial, and you can turn on scrolling as well. Right, thank you very much.